Today, we'll delve on Math 152 Lesson 16, which is calculating present and future value of or at compound interest. In this lesson, you are ought to compute compound amount and compound interest and solve problems involving present value and future value. So to start off, let's have an introduction. When people think of interest, they often think of debt or utang. But interest can work in your favor when you're earning it on money you've saved and invested. Compound interest can be both a blessing and a curse. Compound interest will make a deposit or loan grow at a faster rate than simple interest. When you start off with a sum of money, but over the passage of time, interest is added. This applies to both deposits of money, anywhere you put your money, such as investments or savings, and loans of money. In this lesson, we break down the process of computation of the compound interest and discuss bank scenarios for further understanding of the topic. Let's start now. Let's start to save money. So compound interest or compounding interest is calculated on initial principal, which also includes all of the accumulated interest of previous periods of a deposit or loan. To emphasize it, accumulated interest. Accumulated interest. Thought to have originated in 17th century Italy, compound interest can be thought of as interest on interest, and will make a sum grow at a faster rate than simple interest, which is calculated only on the principal amount. And to add, simple interest is calculated only once in a given time frame. The compound interest formula. The mathematical formula for calculating compound interest depends on several factors. These factors include the amount of money deposited, called the principal, the annual interest rate in decimal form, the number of times the money is compounded per year, and the number of years the money is left in the bank. The amount payable is called the future value, or denoted by A. That's are we going to compute in this lesson. Future value, denoted by A. So to unlock N, because this is unfamiliar to you, or the number of times compounded per unit, these are some of the terms commonly used in solving compound interest. So compounded annually, you're going to use 1. If the problem is compounded semi-annually, you're going to use 2 for N. And if it is compounded quarterly, use 4 for N. And compounded bi-monthly, use 6. So that is every 2 months. And compounded monthly is 12, meaning to say 12 times a year. So bi-monthly is 6 times a year. Quarterly is 4 times a year. So on. So these are transpositions of the compound interest formula. These are the formulas you're going to use in order for you to solve a compound interest problems. So there is a huge formulas. There are huge formulas. So example 1, future value. If you deposit 6,500 pesos into an account paying 8% annual interest compounded monthly, how much money will be in the account after 7 years? So by the question, how much money will be in the account after 7 years? So automatically we're looking for the future value, which is denoted by A. So in order for us to solve for that, we're going to plug in the details or the data given in the problem. So we have a principal of 6,500. The principal is the money at the beginning, the money in the account at the beginning, with a rate of 8%, which is equivalent to 0.08. Again, that is omitting the percent symbol and then divide it by 100 for it to be in decimal form. And compounded monthly, so meaning to say that is 12 times a year. So how much money will be in the account after 7 years? A time frame of 7 years. To solve it, we're going to use the compound interest formula, or the mathematical formula for calculating compound interest. So that is A equals principal multiplied by quantity 1 plus the quotient of rate and number of compounding periods raised to the product of number of compounding periods and time. Okay, so that would be principal of 6,500 multiplied by 1 plus 0.08 issue rate divided by 12, which is n, raised to n is 12 multiplied by 7. So for you to arrive at the correct and exact answer, you have to calculate it once, not one by one. Calculate it once, meaning to say dire-diretso lang. This will yield to A equals 11,358.24. It is advisable to use scientific calculator. And again, I advise you to calculate it once. After 7 years, there will be 11,358 pesos and 24 centavos in the account. For example 2, we have the present value. The problem is William wants to have a total of 400,000 pesos in 2 years so that he can put up a music room. Wow. He finds an account that pays 5% interest compounded monthly. How much should William put into this account so that he'll have 400,000 pesos at the end of 2 years? So what William wants to know is how much money will he put into an account that will accumulate 400,000 pesos after 2 years, or that will be 400,000 pesos in 2 years with 5% interest compounded monthly. So he's looking for P, or present value in compound interest, with the given of, again, after 2 years, this will yield to 400,000 pesos as a future value. Again, in 2 years, rate of 5% or 0.05 compounded monthly, or 12 times a year, the money will be accumulated. The formula would be P equals A multiplied by quantity 1 plus the product of rate and number of compounding periods raised to negative the product of number of compounding periods and time. So that would be equal to A is 400,000 multiplied by quantity 1 plus 0.05 as R divided by 12 as N raised to negative 12 multiplied by 2. Negative 12 is N, 2 is T for 2 years. Again, I advise you to calculate it in the scientific calculator once. Dire-diretso. This will yield to P is equal to 362,010 and 17 cents. So William should put 362,010 pesos and 17 centavos into account for him to have 400,000 pesos within 2 years. Alright, so for you to be guided correctly or properly, see computation taken in a scientific calculator app on phone. So for number 1, for example 1, here's the computation. For example 2, here's the computation. I hope all is clear to you. That's it for lesson 16. Have a good day, class.